Hi everyone, welcome back to my channel Vertex MrRoy. Exercise 7.5 Coordinate Geometry from the Add.Math book. First of all, before starting this exercise, I would like to give some review of this exercise. Is what we should know before starting this exercise. The first thing is how we find the equation of a straight line. And to find the equation of straight line, we normally use y minus y1 is equals to m x minus x1. Remember, in normally like in O level maths, we use y is equals to mx plus c. We do not use this equation in maths, and we can use this equation in Add.Math. But I think so starity is easy to find the equation of like any of two coordinates. Okay, now what we need here, we need to find a gradient here. So we have to find the gradient. The gradient is very important to find, and gradient formula is fixed. Like m is equals to y2 minus y1 divided by x2 minus x1. We need this thing to like in this exercise. The most important like the part in 7.5 is what we are doing, the equation of parallel lines. Remember, when two lines are parallel, this sign is the parallel sign like this. For example, I draw two parallel lines, this one, and second is the parallel to this line. When two lines are parallel, please remember one thing. The parallel does not mean like the line has the same size or not. It can be small, but should be parallel, and it can be like this. There is no problem of the size. Problem is just the direction should be same. So all these lines which are parallel, for example, the gradient of this line is suppose 2 upon 3. So the gradient of m1 will be also 2 upon 3. The gradient of m2 will be also 2 upon 3. And the gradient of m3 will be also 2 upon 3. So it means we can understand one thing: when we have only two lines and two lines are parallel and we have m1 and m2 only, then we write the gradient of two lines like is always equal like this. One more thing very important here. This is most important part here. For example, uh, a line is passing through a point. A line is passing through a point. Okay. Whenever a line is passing through a point, suppose 2, 3 or xy, and equation of the line is y is equals to 2x plus 3 or 2x plus 5. Whenever situation is given, a line is passing through this point and the line is this, please put this value in this equation. For example, this is unknown, this is a, or this is about we have to find this value. This is a, okay. So 2 and 3 will be substituted in the place of x and y. Y is 3 and x is 2. So you can find the value of a. So 3 minus 4 is equals to a, and a is equals to minus 1. This is very important part. Whenever a line is passing through a particular point, put the value in this equation, the x and y. Okay. And one more thing here, like we have simultaneous equation when 2 points, like when we have two like lines, line 1 and line 2 are intersecting. If you want to find this coordinate, this point, so this point means we have to use simultaneous equation to find this coordinate. So let's start with question number 1. 7.5 question number 1 is the equation of the line is passing through minus 1 and 3 and parallel to this. Okay, so it means first of all, we have a line y is equals to 4x minus 1, and we have to find the equation of a second line, equation of a line. So remember, when you want to find the equation of this line and this line, gradient is not, what we need gradient and a coordinate, because we have the equation y minus y1 is equals to m x minus x1. This line is passing through this point, so we have the value of x1 and y1. We have one coordinate, but gradient is not given. So gradient is not given. So how you can find the gradient of because the line is parallel to this line. So it means the gradient of this line will be same as the gradient of the given line, this line. It means We have to find a gradient. Okay, as we know, y is equals to normally was the equation, standard equation of a straight line is y equals to mx plus c, where m is the gradient. So just we have to compare these two equations and just check it out. What is the gradient here? M is equal to 4 because y is alone, c is -1 and m is equals to 4 when the gradient is known now because we got the gradient from this line. This gradient is same as here. I will write is equals to 4. Now, when we have all the values, y minus, because gradient is 4 and the coordinate is given. So now, just put the value in the given equation. Y minus, y1 is 3, m is 4, and x minus 1 is minus will become plus 1 because minus minus is plus. So now we just need to arrange 4x plus 1, 3 shifted to the right hand side become plus, so it will become 4x and plus 4. This is the right equation of the given, like first number 1. You can check the gradient is same 4 and the gradient is same 4 here. We have used it. Question number 2. Find the equation of the line passing through this point. Okay, what we need, what we have to find the equation of a line. And to find the equation, what we need y minus y1 is equals to mx minus x1. This is the standard equation to find. Now, coordinates are given. What are the coordinates? Coordinates are 3 and -2 because the line is passing through 3 and -2. I'm writing here 3 and -2. And what we need just gradient. Okay, and this line is parallel to this line. Okay, there is no difference between question number 1 and 2, but there is one very important part to discuss here because what is gradient here? We have to find a gradient by using, like we have to convert this equation into this form y equals to mx plus c. So we have to make y as a subject. Please do not do one mistake here. There are possible mistakes here. So I want to solve this. Minus 3y is equals to this 2 and this right hand side. So minus 2x and plus 2. Remember, when you make y as a subject, the y should be positive. This should be positive. So there are two possibilities. If you are like good in maths, you can do it like minus will change all the sign here, or you can shift this in right hand side and this in left hand side. So 2x minus 2 is equals to 3y, and 3 will divide, so it will become 2. We can write y is equals to 3 will divide there, 2x minus 2 divided by 3. Still we need to do one thing. This the gradient is 3 will write 2 and with also this 2. So now what's the gradient? The gradient is y equals to mx plus c. So m is coming 2 upon 3. So we can write the gradient is 2 upon 3 now, and we can find the equation y minus 2 will become plus 2 is equals to 2 upon 3 x and then minus 3. So this is like we can arrange this 3 will with 3y and plus 3 times 2 is 6 is equals to 2x minus 6, and then you can write 3y is equals to 2x this and minus 12. There is no need to write this equation in y equals to mx plus c form. This is also okay. There is no problem and you can write it. Question number 3 is find the equation of the line. Okay. I have discussed with you the y is equals to mx plus c, where c is the y-intercept. C is y-intercept. Y-intercept means, what do you mean the y-intercept? When we have a for example here, and we have a straight line, for example, equation is line is passing like this, and this is the equation. So this point, this is called the y-intercept. This is called C. And remember, the coordinates of C are always 0, comma C. Like C is coming, for example, C is 2, so I will write 0, comma 2. So this is the concept of y-intercept. This is the x-intercept, and we do not have x-intercept in the given equation, in the standard equation. So now, once again, the equation of the line with y-intercept is minus 2. Okay, y-intercept minus 2 means we are talking about 0 and minus 2. This is very important. We have a coordinate actually, and the parallel to this line. And parallel to this line means y minus 3xn is equals to 4. So y equals to 3x plus 4. Why we are writing this? Because we need to write with this form, y equals to mx plus c. And what's the gradient now? The gradient is 3. So m is coming 3 now. So now you can find the equation y minus y1 is equals to m x minus x1 and put the value y minus is coming plus 2 is equals to m is 3 and x minus 0 and we got the answer that is 3x and y is equals to 3x minus 2 and we have done it. Okay. Uh, Otherwise, normally we can also use this equation to find this equation of the given line, but there is no issue. Next part is question number 4. In question number 4, we have to find the equation of line passing through this, okay, and parallel to this. Okay, this is the first thing which we are doing, like we have done in question number 1 and 2 and 3. So first of all, we need the gradient here. 3y is equals to minus 4x and plus 5. Please always write x first. Y should be alone minus 4x upon, I am writing directly because we have to write 3 and the gradient is coming minus 4 upon 3. Okay. And the coordinates are minus 2 and 3. You can find the equation y minus y1 is equals to m x minus x1 and there is no problem to find the grade. This is minus 3, m is minus 4 upon 3 and x is minus 2 will become plus 2, 3 will multiply there. So 3y minus 9 minus 4x and minus 8. When we simplify this equation, we can write 3y is equals to minus 4x and minus 9 will become plus 9 and this become plus 1 and we got the equation of the straight line. But did they ask to find the equation? Yes, find the equation, we have done it. Second part, if this is very if p minus 5 lies on the same line, find the value of p. I discussed like in the beginning. You can check. I told you when a line is passing through a point, just put the value. I told you. This is a very important point. So let's consider the same thing like we're doing. This this equation is also passing through uh, p and minus 5. So what I will do simply, I will put the value of x and y in this equation. 3 times minus 5 is equals to minus 4 times p and plus 1. Now you can find the value of p. Minus 4p and plus 1 shifted to left hand side. The minus 16 is equals to 4 will divide here. Minus 4 and p is coming positive 4 and we have done it. So we have the concept here, the lines are parallel, the gradient is same. When a line is passing through a particular point, we can put the value. Question number 5. Find the equation of the line passing through this and parallel to the line this. Okay, in this part, the coordinates are given. So what we need, the 3 and 1 are the coordinates, like coordinates are given. What we need only the gradient. And it's parallel to what? These two lines. So what we can do, we can find the gradient directly from here. Like the formula of gradient is y2 minus y1 over x2 minus x1. So 4 minus 2 is plus 2 divided by 6 minus 3. Sometimes possibles are mistakes are possible. Please, sometime because there are so many numbers, I can do the mistake. So m is equals to 2. So y minus y1 is 1 is equals to gradient is 2 and x minus 3 and we can get the answer y minus 1 is equals to 2x plus is minus 6. So y is equals to 2x minus 5 and we have done it. So next question is question number 6. In question number 6 and 7 I will do together. This is like very simple. Find the coordinates of the point of intersection. So remember, these are non-parallel lines means we have some intersection. Like intersection is there like this. So it means please use simultaneous equation. I'm just doing question number 6 part A. If I just add these two equations, if I add these two equations, this will be cancelled out, and 4x, this is coming 7x and minus 7 equals to 0, x is equals to 7 upon 7 is 1. Then I can put this value of like x in the first equation. So it's coming y is equals to 4, this minus 2 is 2, is minus 2. The coordinates coming 1 and minus 2, and we have done it. Like this is very simple simultaneous equation. You can use any of the method. Even you can see my one of the video. I use very simple, it's easiest method in that. So question number 7. Straight line passing through this point. Okay, we have two coordinates. When the straight line passing through two like points, can you find the equation? Yes, we can find the equation. Equation 1. Equation 1. This is question number 7. We can find y minus y1 is equals to m x minus x1. So from equation, you can find the gradient first. Like from the gradient first, gradient is minus 3 divided by 5 plus 1 is coming minus 6 upon 6 is minus 1 is the gradient. You can use any one of the coordinate like minus 1, 3 or 5 minus 3 is up to you. You can find the equation. There is no problem to find the equation number 1. And second thing is given, this equation intersect with this. Intersect the line with this at point P. Find the coordinates. What do you mean by this? When you have the equation from this part, equation 1, and this is equation number 2, we can use simultaneous same like question number 6, and we can get the answers of P. Like there is no problem to find the coordinates because we have two equations. One equation we can find from here, and second is given. Okay. Question number 8 is about, let's see if I do question 8 and 9 together because I don't want to make two videos for this exercise. Find the equation of the line parallel to this. Okay, so it means the gradient will be the same and passing through the point this and intersect this. Oh, like the concept is like I would like to not solve the whole question, just to give an idea how we can do this question actually. Okay, now what we're doing here, the equation of the line is parallel to this, so I can find the gradient first. 2y is equals to, I will write x first, minus 3x and plus 6, and y is equals to minus 3 upon 2x and 6 upon 2. I'm writing directly. So gradient is minus 3 upon 2. Okay, we know the gradient. What we need to form, like to form an equation, a coordinate x and y. Okay, we need a coordinate. And this line, which we like have to find a line. This line is parallel to another line, like this. Okay, this is the required line. This is the required line, and this gradient is this line 3x plus 2y minus 6 equal to 0, which has a gradient minus 2 upon 3 upon 2. So this gradient is also minus 3 upon 2. We got the gradient. So what we need to find the equation of this line? A coordinate, any one coordinate. And passing through the point where this intersect this, it means this line is also intersecting two more lines like this. This is here. I can use the color. And the second line like this. We can use different color. So it means this point is point P. So when this line is x plus y plus 2 equal to 0 and this line is 3x. Now, what you can do by using these two lines, like these two lines, we can use simultaneous equation to find the this coordinate. This coordinate we can find. When we know this coordinate, then what we can do, we can use this coordinate x and y here. and gradient is already given. We can find the equation y minus y1 is equals to m x minus x1. I think it's easy now. So question number 9. In question number 9, we have a line parallel to this. So we can find the gradient is coming directly. Y is equals to 2x plus 3, meaning the gradient is 2. You can see. Okay, and passing through the point this. Okay, and the passing through the point this means, can you find the equation? This equation 1 is very simple to find. There is no problem. Okay, this is the first case. We can do it. Intersect. Oh, intersect, like this is intersect means if you know this equation, and what is the second equation? Another line this at point P, find the coordinates of this is like, okay, good question. What we can do, this equation y is equals to, first we need to find the equation, there is no problem. We have to find the equation 3x minus 11. We have to find this equation, and this equation is already given. This is equation number 2. Can we use, and these two lines are intersecting at point P, like two lines. This line is here, and this line is here. This is point P. So by using this equation and this equation, we can use simultaneous equation method and find value coordinates of P. And I think so it's easy. You can do it. Question number 10 is to find the equation of the line parallel to this and passing through the point this cuts the x-axis. Okay, actually one more thing, like on x-axis or on y-axis, the coordinates are fixed. On x-axis we have x comma 0. On y-axis we have 0 comma y. These are the fixed coordinates. We cannot change it. So just remember, or even when you have a sketch, you can see by this sketch you can understand like this. And we have a line, for example, a line is like this. So this line, when you see this part, this is 0 comma y, and this is x comma 0. So this is fixed. Find the equation of the line this. Oh, sorry. Find the equation of the line parallel to this means we have to find the gradient. Y should be positive. So y is equals to, please do not do it directly. Sometimes mistakes are possible. So the gradient is coming minus 1 upon 3. And passing to the point where this curves the x-axis. So it means the coordinates are not given here. So what we can do, we have to use this equation. And this equation is passing through which coordinate? 3x minus 2y plus 6. Okay. Find the equation line parallel to this. We got the gradient and passing through the point where this cuts the x-axis. So actually, we can see like this. Like this coordinate and this coordinate cuts at x-axis. So can you find the coordinate on x-axis is y0? This whole is 0. So x is coming. Minus 6 upon 3 means is minus 2. So coordinates are like we can write minus 2 comma 0. So I can use the same coordinate here minus 2 comma 0 because this line passing through the point where this cuts the x-axis, both the coordinates are same actually. So we can use and find the equation y minus y1 is equals to, if you have some doubt, I think so we can check the answer is minus 0, m is minus 1 upon 3, x minus 2 is plus 2, 3y is equals to minus x and minus 2, and we have done it. Let's check the answer of question number 10. Yeah, question number 10 is here. X plus 3y plus 2. X plus 3y plus 2. So x plus, if you want to write this, okay, x plus 3y plus 2 equal to 0 is same. We have done right. Perfectly good. So next is question number 11 and 12. If there is no change in this question, then I will just explain how to do. The line this is parallel to this. So gradient is same. We can have the value of A. Okay, and passing to the point this. Okay, this is good question. I'm doing 11 first. 11 y is equals to ax plus b. and is parallel to this line y equals to 2x minus 6. So gradient is here 2 and the gradient is here a. So the a is coming 2 because they are parallel. Please do not write b is minus 6. Gradient, the value of a is known now. So y is equals to 2a plus b. Now this line and this line is passing through the point minus 1 and 7. I told you, when an equation is passing through a point, just put the value. Y is 7 is equals to 2 times minus 1 and plus b. And we can get the value. This is coming minus 2 is coming, b is 9. We got the value of a and b. Check the answer. A2, B9. We have done it right. 2 and 9. Good. Question number 12, which is the last question of 7.5. Let's see. Prove that this line, this line and this line are the congruent, they intersect at only one point. So actually in this equation, I just would like to give one idea is how we can do it. We have a formula actually. I have a formula. I can use that formula to find the direct coordinates. But you have to do one thing. We have equation 1 and equation 2 and equation 3. If you use equation 1 and 2, you will get a coordinate like point of intersection. For example, you're having 2 and 3. When you use equation 2 and 3 is also coming 2 and 3. And when you use equation 1 and 3 is also coming 2 and 3. There is, I mean, this is called at one point of intersection. So by this way, we have done exercise 7.5. I hope this you like my video. This is useful for you, the students who are like at home, not going to the tuition. And next video will be definitely about 7.6. Thank you so much and have a nice day.